In this video, you're going to learn how you can build a complete RAG application that is allowing you to privately chat with your PDF documents using only open models. And with this application, you're going to be able to upload a PDF file, such as this one that I'm having right here. After your document is ingested by the system and analyzed, you can ask your question. So for example, I'm going to be asking what is the engine of the car, since I've uploaded a PDF about a specific car. And you get your response, and pretty much this is correct. And also, along with the response, you get the 3 sources that the RAG system has used for retrieval. And these should be ordered by their relevancy first. So we'll have to have a look at how we can do that as well. Hey everyone, my name is Valerin, and in this video we're going to be building a completely local RAG application. We're going to be using only open source tools and open models that we can host on our own machine. We're going to be building the RAG application along with LangChain and Streamlit, and finally we're going to be deploying the complete app on Streamlit Cloud so others can share it and try it out. Also, I want to introduce you to my friend that we're going to be using right here for the LLM. And this is the Llama 3.1 version of the Llama models. And his name is Petko. So say hi to Petko. Petko is going to be helping us as the most powerful open LLM that we are going to be using for our RAG application. Let's get started. If you want to follow along, there is a complete text tutorial that is available for MLExpert Pro subscribers, and it is within the MLExpert.io bootcamp. On the bootcamp, and then we have a new section called projects, and the first project right here is going to be RagBase, or the current local RAG application that we're building. Here you can find a complete tutorial along with the link to the source code and a lot of documentation or text that is explaining the complete process of building this local RAG application. So if you want to support my work, please consider subscribing to MLExpert Pro. Thank you. Our RAG application consists of 2 main processes that allow it to work and help the users answer their questions based on the provided documents. The first part is going to be the ingestion pipeline. So the ingestion pipeline's job is to essentially get the document or the PDF files from the users and convert them into plain text and chunk them into smaller pieces. So we can essentially provide these documents to an embedding, in our example, a vector database, and use this database as a source of knowledge so we can answer some questions based on the query that the user has provided. So for this to work, we need some PDF documents that are going to be provided again by the user. Then we have a document loader, and in our case, we're going to be using a specific library that is called PDFium2. And in this case, this library is actually created by Google engineers, and in my experience, it works pretty well. It is quite good PDF library, and I'm going to show you why I have chosen this specific library as well. Then we have a chunker and a text splitter. Essentially, both of those are splitters of the text, since if we provide the complete PDF text from the documents, we can essentially get outside of the limit of our LLM, or we can provide too much information for the LLM to have something that is irrelevant to the query, which ultimately can be a challenge to the LLM, and the responses might not be as good as we want. And finally, throughout some embeddings, we are going to be essentially converting the text into embeddings and storing them into a vector store. In our case, we're going to be using the Qdrant library or local client, in which we're going to store the vectors, and this is going to be our essentially vector database. After this step is complete, we have another component that is really important, and this is the retrieval. And this is essentially invoked every time when the user asks a question. And since we already have a vector store of knowledge, we can essentially create this component that is known as the retrieval or the retriever. And in this case, we have a user right here. This is the MLExpert logo, of course. and we have what are penguins known for, which is going to be a question or a query that the user is providing. And we'll have a LangChain question and answering chain that is going to be essentially the facade or the front of our own application. And in this case, this facade is going to be working with an LLM. In our case, we're going to be using Llama 3.1 and Llama 2. And then we are going to be essentially providing the query again to the retriever. And this retriever is going to be using the user knowledge in order to get some information and return it. And after this step is done, after those chunks of text that are most similar to the user query or most relevant to the user query, we're going to be essentially re-ranking those using a Reranker. And the job of the Reranker is to essentially give us a correct order with the most relevant document at the top. And after the Reranker is done, we are going to be using an optional LLMChainFilter. And I'm going to show you what the LLMChainFilter does. Essentially, those are filtering and re-ranking techniques that should improve your LLM performance if the models within those are performing a good job. And after those steps are complete, we're going to be essentially providing the context from the retriever to the LLM. And the LLM is going to be using the user question along with the context and provide an answer that is then returned to the user. Here I have the RagBase project opened within Visual Studio Code. I'm using Python 3.12 in order to run this project. And within the Py project, you can see the dependencies. Also, again, if you want to have a look at the complete source code for this project, please consider joining the ML Expert Pro Bootcamp. From that, I'm going to link the GitHub repository for this project. And the more important parts right here is that we are using LangChain along with the LangChain community and LangChain experimental dependencies, LangChain Qdrant along with the Qdrant client. Those dependencies we're going to be using for the question and answering chain by PDFium2, which is going to be our PDF loader. And then one more important dependency right here is the Streamlit, which we're going to be using to build the UI for the project. So first, I'm going to start with the app.py, which is essentially at the top level of this project. And here you can see that we are essentially using a lot of imports from the RagBase project, which are within the RagBase directory right here, which we're going to go through in a bit. And from here, you can see that we have a lot of imports and then some loading messages that we're going to be using, along with pretty much the more or most important part of this file, which is the build question and answering chain. Here, you're accepting a list of files. And first, we're going to be uploading these files. I'm going to show you the uploading files in a bit. And then I'm calling a class that we're going to be calling just ingester. And it's going to ingest essentially the files that we want. And from that, we're going to be getting a vector store. So this is the ingestion part from our diagram. And after that, I'm going to be creating a large language model with this function right here, create LLM. And from that, I'm going to be also creating a retriever. The retriever is going to be also accepting the LLM along with the vector store. For the LLM part, we'll be using the LLMChainFilter, which is optional, but still it requires the LLM. So in order to create the question and answering chain, I'm going to be calling this function createChain, which accepts an LLM and a context retriever. In our case, I've shown you the diagram, and this is pretty much everything encapsulated into this single function. One important part is that we are actually caching this resource, so we are not going to be recreating this over and over again for each refresh of the Streamlit application. And this will allow us to essentially download the models at the start and then don't redo this every time that something changes with the UI. Next, we have a couple of helper functions. First of which is the askChain function, but I'm going to show you the functions themselves in a bit. I want to just show you first how we are going to be initializing this Streamlit application, which is pretty standard. In our case, I'm going to be configuring the page, setting just RagBase as a name of the project, and I'm going to be adding a penguin as a page icon. Then I'm going to increase the size of the heads for the avatars within the chat application. It's a bit of a hacky way, but I'm targeting essentially the div that is the class of the div, that is this right here, and this might change if you upgrade the Streamlit version, but currently this appears to be working just great. And then we are going to be creating the messages, which are going to be for the chat. And if there are no messages, we are essentially going to be getting the welcome message for the bot. And after that, I'm going to also putting a limit on the number of messages that the conversation can have, since I'm going to be uploading the demo and I don't want this demo to be essentially abused too much, since I'm also adding my own keys to the demo. So I'll show you the config in a bit. After this is done, I'm going to be essentially showing the UI for uploading of the documents. Then I'm going to be showing the message history. And after the message history has been shown, we are going to be displaying the bottom part of this application, which is essentially going to be the chat input. And just to make everything a bit clearer, this is the message history, this conversation up to here. And then the show chat input task is to essentially give us this input at the bottom right here. So this is essentially the UI that we are going to be building. Now let's return to the ask_chain function. And in this function, we are essentially using the Streamlit chat message helpers, which are a way to build a bit faster chat-based applications. And here we have a chat message with an assistant for the name. And to the assistant, I've given it a PNG file, which is going to be the custom image that we have. And when the assistant is done, I'm going to essentially be showing a loading message if everything needs to be, we are waiting for the response from the LLM or something else. Please note that the ask_chain is actually a sync function, and we're going to be calling this in a bit. So this is an async function because when I ask a question to the chain, which is going to be from the RagBase application, this function called askQuestion, I'm going to be essentially giving the question and then a session ID, and the response is actually going to be an async generator. So for this to run, I'm going to be using an async for each loop, and if the event is a list, I'm going to be essentially adding this to the response, and if it is a string, and if it is a list, I'm going to be essentially counting this as a source for the document explanation. So let me show you again why this is important. This part right here on the right, when this is actually a string and this is returned from the ask question as an event, this is actually part of the response that we need to stream. But if this event is a list, I'm going to be essentially adding the list of the source documents, which are these right here. And these documents are going to be presented into these expandable elements. So after this is complete, you can see that I'm actually enumerating the documents, and I'm actually visualizing the sources along with the expander right here, which is this thing that you can expand and close and have a look at what the source of the document actually is. And after this is complete, I'm going to be adding the complete response to the message state. So our chat history is going to be complete. Okay, the next function right here is the show upload documents. It's pretty straightforward, very similar to what we have in standard Streamlit applications. And first I would require the users to upload a PDF file. And while the uploading is complete and building the whole chain is complete, I'm going to be essentially displaying this spinner, which is calling the build question and answering chain. And I'm saying to the user that your documents are essentially currently being analyzed. Okay, the show message history, again, pretty straightforward function. And we are essentially creating this chat message container with the avatar and the role for the avatar, which can be a user or assistant. And then I'm displaying in Markdown message the content of the chat message itself. And the input is, again, something pretty straightforward. I'm asking for chat input, and this is going to be the prompt that we're going to be using for our question and answering chain. And I'm appending this as a role user to the chat history that we have thus far. And with a new container and an avatar for the user, I'm going to be essentially displaying the message as the enter key is pressed. And after that, I'm going to be using the async.io internal library for Python to run the aschain function, since this is our way to bridge the synchronous with the asynchronous type or part of the question and answering chain. Next, I want to show you a couple of other interesting parts of this project. Within the config, I'm going to start with that. You see that we have a lot of configuration for path. This is the directory of the database, the documents that we're going to be uploading, images directory, which is essentially going to be using just the images that we're going to be using for the user avatar and the assistant avatar, a collection name for the document, since this is required by the Qdrant library. And then we have a lot of components. You can see that the embeddings and the Reranker models are essentially fixed, but the RagBase library, you can essentially choose to use a local large language model or use a remote one using the Grok API. In this case, I want this to be using the local LLM, and we're going to be using this with the Llama instance that you need to run locally, and you need to have this model running or available within the Llama instance. Then for the retriever, you can enable the Reranker and the chain filter. The chain filter can be quite slow, and if you don't have enough resources, I would recommend to turn it off. Even though your performance might suffer, still the chain filter can slow down a lot the RAG application, but the Reranker is quite fast, so I'm enabling it by default. And this is the conversation limit, up to 6 messages in total. So let's continue with the uploader part, which is going to be pretty simple. In our case, we receive a list of files, and I'm going to be essentially removing the previous cache of files and database files. So if this flag is enabled, which it is by default, I'm going to be removing everything within the database directory and the documents directory. And after this, I'm going to be creating the documents directory. And for each file, I'm going to be essentially writing the path of the file within the documents directory and appending this to a list of file paths. So this list is going to be actually returned. After this is returned, we from the app.py, let's again show you the process. So after this upload files is complete, I'm going to be calling the ingester.ingest. So let's continue with the ingester. As you can see, this is a class that we have created, and within this we have the embeddings, semantic chunker, and then recursive character text splitter. So why we need all of this? Essentially, the ingester's job is to get the PDF files that we're going to be uploading and converting them into text files, and then splitting the text into smaller chunks and using the embeddings to save the chunks within our vector database. So how this works in the RagBase application, I'm going to show you how the ingest method is working under the hood. As you can see, it's pretty straightforward code. For each document, we are essentially reading the text of this PDF file using the PyPDF EUM2 loader, which is provided by the LangChain community loaders, which essentially is calling the PyPDF EUM2 under the hood and getting the text of the documents. And After that, we are essentially getting the complete text and joining it together. After the text is joined, I'm going to be calling the semantic splitter, which essentially uses some type of, it uses the embeddings in order to do some semantic analysis and similarity search between the different chunks, and based on that decides how large the sentences or the complete paragraphs should be. And even though this is great, in practice you might receive chunks that are way larger than you need. So for example, you can get a chunk that is over 10,000 tokens, for example, which is quite large, and you might get out of the context length of your LLM. So in order to prevent this, I'm using this recursive text splitter, which essentially is going to apply a hard limit on top of the semantic chunks and further split the texts. After this is complete, I'm going to be essentially creating the final documents that we have. And those final documents, I'm going to be creating this Qdrant instance, which is a vector store. And I'm going to be passing in the documents along with the embeddings for the documents, the database directory, and the name of the documents collection. So this will essentially go ahead and create this docsdb along with the meta. You can see here, we have a lot of information about the database and the documents collection right here, along with the collections, which under the hood, if you didn't know, actually Qdrant is using SQLite. So this is pretty interesting if you're interested into the implementation details of those types of libraries. Why did I choose the PyPDFium2 as a PDF loader? Well, I went through the benchmarks in PyPDF on GitHub. So in this repository, they have a set of input documents, only 14 of those, and you can go through those. And they're essentially comparing different libraries. Now this benchmark is a bit old. It looks like the latest push was October of last year, 2023, but still it is a good starting point, at least to me. And they're comparing text extraction speed with text extraction quality, which are the two most important parts that I'm at least interested in when building the RagBase application. And you can see that at second place for text extraction speed, we have the PyPDFium2. And for text extraction quality, PyPDFium2 is at the first place. So it wasn't really a big challenge for me to pick this library, speed and quality for text extraction. That's how I end up with this. After we've seen how the ingestion works, let me show you the retrieval part of our own diagram. Again, this is this retrieval part that we're going to have a look at. So the retriever is actually pretty simple. We have a single function called createRetriever. Within that function, the requirements are that you're going to be passing in the large language model and then a vector store. The LLM, I'm going to show you why you need it, and it's kind of optional if you're using the LLM chain filter. But in this case, if you're not passing in a vector store, the function is going to be initializing one for you based on the configuration for the documents collection and the database directory from Qdrant. After that, we're going to be creating a retriever, which is going to be using similarity search, and it is going to be fetching the top 5 most relevant chunks or documents from the vector store or the knowledge base that you have. After that, if the Reranker is enabled, we are going to be using this compression retriever with the compressor of the Reranker, and then the retriever as a base retriever. And if the LLMChainFilter is also enabled, I'm going to be creating LLMChainFilter from LLM, and I'm going to be essentially passing in the retriever that we have thus far, and I'm going to be returning the results. So this looks cool. The code is pretty simple, but let me show you a bit how actually these types of retrievers and reranking works in practice. So here I have this notebook within the RagBase repository. And here you can see that I'm actually importing the Reranker, create large language model, and the LLMChainFilter. And I'm saying that I want this instance of the LangChain library to be a verbose one. So I'm going to be creating the Reranker. And I'm going to be creating a couple of documents, which are essentially from the document that I'm using as a demo for this project. The PDF itself contains a lot of information about the new Porsche GTS, and this car is for the year 2025, so those models don't have any knowledge about the car. And here we have some passages or paragraphs from the PDF itself. And for the Reranker, I'm going to be asking it what is the price, and I'm going to be passing in all of the documents right here. And you can see that if you run through this, the first document, it's going to be the one that contains the price of the GTS Coupe, or at least the starting price, of course, since with options you pay a lot more if you get it, of course. And along with a score of relevancy. And you can see that this didn't score very well, but compared to the other paragraphs right here, which of course didn't contain any pricing, this scored somewhat relevant. And this is the text. Note that here the document with the most relevancy was at the last place, but after running the Reranker, actually this is the first document right now, or the reorder is that this is the first document, which works great. And we're going to be using this when we're creating the prompt for the LLM. And then for the LLMChainFilter, this is again a very simple processing or filtering task. I'm going to be creating this chain filter. I'm going to be calling the compressed documents, again, the same documents that we have, how many seats are in the car. And here you can see that, again, the same document is the only relevant one, since this talks about that the back seat is no longer standard. Adding the 2nd row is a no-cost option. And based on that, you can see this chain filter is actually calling the LLM with a specific prompt. And here is the prompt. Here is the following question and context. Return yes if the context is relevant to the question, and no if it isn't. And this is the question, how many seats in the car? So this is taken from our prompt. And this is the context with the different paragraphs passing out. And you can see that actually after this chain is complete, we have just a single document that has passed through this filtering. In our case, this was again the most relevant document, and the other one were cut off. So essentially you can use these techniques to reduce the number of documents that you're providing to the LLM and increase the accuracy of the responses, since your LLM doesn't have information that might collide with the internal knowledge or processing or thinking of the LLM, if you will. Of course, you might miss some relevant information with the Reranker or the LLMChainFilter, and would probably be a great idea to do some RAG evaluation to know whether or not those components are actually working and helping you out, or essentially destroying the performance of your RAG application. But in this application, with the PDF files that I've seen, this appears to be working quite well. The next part of the project that I'm going to show you, let me close this, is the actual question and answering chain. And I'm going to show you the chain.py file. So we have pretty much all of the components that we need. And this is the system prompt that I'm going to be passing into the LLM. Utilize the provided contextual information to respond to the user question. If the answer is not found within the context state that the answer cannot be found, prioritize concise responses. The contextual information is organized with the most relevant source appearing first. So this is really important, since I'm telling the LLM, hey, at the first document, there should be the most relevant information to the user query. So use that. And this is the context. and I'm saying that I want this to use the markdown formatting as much as possible. And here I'm applying remove links and format documents. This is going to be essentially getting the documents and converting their page content into a text, and I'm going to be splitting between different documents with a horizontal rule, as you can see that I've set within the prompt of the model. So this is essentially the create chain function, and here I'm going to be using the chat prompt template. This is going to be using the particulars model prompt template, and I'm going to be creating these messages with the system prompt, message placeholder for the current chat history, which we're going to be supporting right here, and a question from the human. So essentially this is going to be an array of the messages or a list of the messages. And after that, I'm going to be asking the retriever for the context based on the question. So this is the question, the retriever, and after this is run with the runnable pass-through from LangChain, I'm going to be calling the format documents. So for each document, we're going to apply the format documents function. Again, this is the format documents, which accepts the list of the documents that we find from the retriever. After this is done, the retriever's context is going to be given to the prompt. The injection of the context is going to be happening within the system prompt right here. And then after the prompt is complete, I'm going to be calling the LLM with the final prompt. After this is done, this is going to be essentially be the chain. We need to essentially fill in the chat history within the prompt. And I'm going to be using the get session history, which I'm going to show you in a bit how this works. It's pretty simple. It is essentially a built-in memory system. And this is going to be essentially inputting the chat history within the prompt. After this is done, we can essentially get this chain and ask it some questions. Here, I'm also defining the ask question function. And as you can see, this is async stream events function. This is using essentially the way that I want to stream or to split the context from the streaming response, since the context I'm going to be using to return the sources of the documents that the LLM is using. And here I'm applying a console callback handler if I have enabled config debug, and if you do the enabling of the debug function, you essentially see the complete output from the chain, which is quite verbose, but you can use it to filter out some information if you want to. And here are the two things that I'm interested in with these include names. It is the chain answer, which is going to be essentially the output of the LLM at the end, and then the output of the context retriever. This is where we're going to be getting the documents that we are interested in, and we're going to be displaying those as sources for the response. So if the event type is on retriever end, I'm going to essentially output the documents that are gotten from the retriever. And then on chain stream, I'm going to essentially stream the chunk of the data. And for the session history that I've promised you to show you, again, pretty simple, chat message history. And for a given session ID, if this is not within the given store right here, I'm going to enable this to run. Otherwise, I'm going to be essentially creating this right here. Probably I can use a default dict, which will be much better compared to this, but either way, this is a very simple implementation of the session history. The last file that we're going to have a look at is the model.py. And within this file, we're going to be essentially initializing all of the model that we need. And for the LLM, as I've already told you, we have a local option, which is using the chat or Llama. And in this case, I'm going to be getting the temperature, the maximum number of tokens, and the name of the LLM from the config file. If I don't use a local LLM, I'm going to be using the Grok API, as I've already told you. For that, you need to have an environment file, which should contain your Grok API key right here, as I've shown you. And if you have this, you can, of course, use the Grok API to do the LLM part. The keep alive option right here allows you to say that the Llama instance should keep the model in memory, so you don't have to reward the model every time that you're asking it something, which is pretty helpful and speeds up a lot. For the embeddings, we have fast embeddings with pretty much the default embedding model, but the base version of it, this is a bit larger compared to the mini or small model from here, and I think that these embeddings work quite well, at least for English, of course. And the latest or the last one is the FlashrankRerank with the MS macro, sorry, not this, with the mini LLM macro Reranker. Again, FlashrankRerank is really quite fast, and it works really well with this pipeline. So we are ready to run the application. In order to do that, I'm within the Poetry shell or virtual environment that I already have installed. I also have the Llama instance running locally on my machine. And after that, I need to essentially run Streamlit run op.py. And this should run the project on your local machine, and you should get this UI. After this is done, I'm going to get a PDF file that I want to upload within the RAG application. And this PDF file is going to be analyzed by our system. Of course, this is all done locally on your machine, so this might take some time. This is the PDF that we're going to be using. As you can see, it has some photos, some different formatting of text, again, more photos with links, etc. It looks like a proper PDF file with some formatting and tables, etc. We're going to be using this in order to test our model. And again, this particular PDF is about the new Porsche Carrera GTS that is coming out as a 2025 model. So this is provided article from 10th of July of this year. So those models don't have any knowledge, at least according to their authors. Our knowledge cutoff was well before this PDF was released and the information about this car was released. And this PDF, again, is quite technical. It provides a lot of details about the car, the engine, the horsepower of the engine, etc., etc. So we're going to try to have a look at how our RAG application is going to be handling this type of somewhat complex PDF. Now that RagBase have analyzed the information about our documents, we can start by calling or asking for information. What is the engine of the car? And this is running completely locally using Llama 2, 8 billion parameter models. And since the model was already loaded within the memory, you can see that the responses are quite fast. I have the base level MacBook 14 M3 Pro. And again, the responses are quite good. What is the acceleration of the car? Again, this is completely real time. Yeah, the response appears to be quite correct. How many seats are in the car? Okay, we've seen with the reranking and the chain filter that this is exactly correct. Comes standard as a two-seater, and you can add additional 2 seats, and you can have a look at the information or the chunk of data that was used in order to get this information. To deploy our RagBase application, I'm using the Streamlit Community Cloud, and they have a complete explanation or way of how to actually deploy your application, which is pretty easy. And essentially to do that, I had to do some configurations in order to run through this. but I'm going to show you the backend of the configuration file. You can see my application right here, and you essentially need to go to this create your app. And if you have an app, you can point it to a GitHub repository. And from there, you have to essentially configure a lot of some part of details that you might require. So in order to run with this, I also decreased the max upload size right here, and have created a theme for our application in order to change the information of the covers of the files. I have also exported the requirements, since I don't want the remote version to have something like Llama, since this is not required or it won't run quite well on the community cloud. You would need quite a faster or more powerful machine. So I have exported the requirements, and these requirements are used when the machine for the RagBase on the Streamlit cloud are uploaded. Of course, you will also need to use the Streamlit secrets in order to provide your Grok API key if you want this project to run on the Streamlit cloud. And other than that, this app is running as is from the GitHub repository. And you can find the complete demo at ragbase.streamlit.app. So this is it for this video. With the help of Petco right here, we've shown you how you can build a complete local RAG application that you can use in order to even deploy on the Streamlit cloud or your private instances. And we've seen how you can use a somewhat complex application to create an ingestion, then create a vector store, use a Reranker, chain LLM filter along with a local or a remote LLM, and finally build a question and answering chain that you can essentially hook up to a Streamlit application to provide a nice UI for chatting with your documents privately. Again, if you want to follow along, have a look at the source code and the complete tutorial, please join MLExpert Pro subscribers or bootcamp. I'm going to link down this into the first comment of this video. Please like, share, and subscribe. Also join the Discord channel that I'm going to link down into the description, and I'll see you in the next one. Bye.